Now, I like to use robotics in Kerbal Space Program, and I want to show you how I use robotics to land rovers using probes, being able to fit it all into a 2.5 meter rocket. Now, this build does require mods Infernal Robotics and near future launch vehicles. Now, to launch these rovers, I'm going to use an extended version, not an extended version, but a slightly modified version of the rocket I showed you in the last tutorial, the Rigel I. Yet again, since I suck at talking about stuff on the spot, I'm going to create an audio overlay talking about the rocket and the Rover Landing module. This rocket shown in the video weighs 709 tons and it's a modified version of the Rigel I. The only modification difference is that the docking port, which is usually on the Mark 1 to 3 command port, is replaced with a TD12 decoupler. This is to prevent any driving issues with the docking port being placed at the bottom of the rover. Now, the landing module uses a probe core, specifically the one shown in the video, to be able to use SAS accurately with the retrograde node to allow for easy and fuel efficient landing. It will be a lot harder to control without this. The satellite shown on the top of the rover landing module is used to convert the lander into a small landed relay. This allows the rover to communicate with Kerbin from the surface and allows you to use it. It's also using 4 radial fuel tanks on robotic hinges and extendable arms, and this is to allow a more stable landing and for it to be done with room for the rover to land safely. Now, this may create part clipping, which isn't the best thing, but just in case of any mess ups, make sure you save throughout the flight. I'd recommend landing on the Kerbin side of the moon, which is stuck in a tidal locked orbit around Kerbin. Unless you have an active relay around the moon, then you should do this. Due to potential robotic cracking issues, make sure to lock your robotics before and between uses. If not done, there is a chance they could turn into spaghetti during flight, and I mean that quite literally. I will link all the mods needed and a handy mod manager in the description if you need them. Now, moving on to flight, which I will timestamp in the description if you want to skip straight to the Mun Landing.
Chuki got the sauce, bitch.
I'm able to get 6.6 thousand delta V from this, which isn't too bad, and we're gonna launch now. So, some stuff about these. There's some part clipping going on here, but that's fine. The satellite dish at the top is a nice feature because it allows the rover to talk to the. It allows the probe to act as an antenna for the rover to be able to talk to Kerbin. Now, if you don't have any satellites in orbit of the moon, I definitely recommend landing this on the Kerbin side so that you are actually able to communicate with Kerbin, or else you're kind of screwed. The way I like to do these launches is I'll get this into a nice low orbit of the moon, and then I'll get rid of this, and then what I'll do first is I'll get the kerbals back to Kerbin, and then I'll use this the payload. Because I added a probe core, it has inbuilt SAS, and I'm able to use that to essentially wirelessly land it while these people are back safe. This is just to make sure that these guys do get back safe, and it evades these people having to actually land on the moon, which would end up using a lot more than I want. So if we get into orbit here, like that, okay. This stage alone will be able to handle that. We've got too much delta V in here, but I don't really care. Essentially, I like using this rocket because of its delta V. Whenever I do a mission, I end up having like 3,000 spare. If you are playing career and you do need to save money, then I would recommend cutting down on delta V until it suits you, either by getting rid of some fuel engines, either by getting rid of some fuel containers or engines themselves, or cutting back on the solid rocket boosters. But we launched this rocket with about 6,000 delta V, so you could theoretically land these people on the moon as well to give it to the rover, but it would be a lot less, you know, a lot less practical. So it's very important that you lock these robotics before you launch, or else they'll flail around and end up breaking your craft or making it unstable, which is very annoying. So make sure you lock these before you launch, or else it'll be, yeah, just incredibly annoying, if not impossible to launch. So essentially, what I was going on about earlier, when this lands, this dish here is connected to this, and the rover disconnects from this, and then from here the rover can connect to this to act as a small satellite, and this will connect to Kerbin. Well, this might be too weak to talk to Kerbin, it might not be, but yeah. Unless you have satellites or like relays in orbit, I really would recommend adding this to the top, or just any satellite with enough reach, really, as long as it works. But yeah, we're just gonna focus on landing now. So what I like to do is I like to get down to an orbit of about 20,000 meters, because this thing doesn't have much delta V. I'd say when you do get to the moon, it has about, well, it does have quite a bit. It has about 1,000 to 2,000 delta V, which is enough to land from a low orbit of the moon. And it's best you get it low so you don't have to burn as much to shorten the orbit. And because I can't put a parachute on top of this now, I put a radial parachute on just so all three of these can land and be fine. If you don't want to put the parachute, then you don't have to, but when you do bring these guys down, you might have to control each of them through their parachutes to land them more safely. But I mean, entirely it's up to you. What I've done is I've put some radioisotope thermoelectric generators or RTGs on, just so they generate electricity constantly. A big issue is running out of electricity. That happens a lot, and using RTGs instead of solar panels, like, first of all, they're more reliable and less prone to breaking, and I don't have to, you know, forget to open them because they just work nonetheless. So I'm just gonna get here and let it burn. That's perfect. When you're burning, I'd recommend, you don't have to do this, but I'd recommend getting your node in T to about half of the burn time, so that it balances enough on this side as this side. And essentially it will make this perfect, because if you do it too early and say it's here, then it will probably be off a little bit. But if you do it halfway through, then you should be fine. So I'll come up here. And we'll reach there. That's about as good as we're going to get. 3 hours. We want to get this into an orbit, which actually it kind of wants a lot of. Get to a 20,000. And then here, just to make sure I don't, you know, overburn and make it too low, I like to lower the thrust limiter. It's just to be safe and a bit more precise I'll do it to like 20 or so now. So then we have 1 minute 41 at burn time, but I'll skip past that because, you know. Actually, you know, I'll put it up to about 70, just so I don't have to skip over it. So there's only 29 seconds of burn. We'll go to the maneuver. The reason I do it here specifically, or at least the burn here specifically, is because you have your Mun, you have it orbiting around here, and in about 5 hours you'll encounter it. So it takes about 24 hours for it to orbit, and you want to see where it will be in about 5 hours, which is about, say it was here, and since 1/4 24 is 6, it'll be here in 6 hours. So say it was here, then you go like 1 hour, 2 hour, 3 hour, 4 hour, 5 hour. Say this was 6, 5 would be about here, so I just did it here. You can move it around. It's a nice way, nice easy way of, you know, getting an intercept of the Mun pretty well. I use it a lot now, and I don't really ever have any issues with encountering the Mun now because of the way I do it. So we're going to burn until this is down a bit. Roughly 20,000. That'll do. And then we'll come over here, we'll do this down a bit to about there, that'll do. This is actually a good position because both the sunlight and Kerbin is, you know, aiming on roughly this area, which is facing Kerbin. And you want to be facing Kerbin when you land, for reasons I said earlier. The reason I don't do this with just the probes is because when you're on this side, you still don't have, you know, control. The reason I do it with the kerbals is so that you have full control all the time, and say you want to, you know, lower your orbit from this side, then you're not really restricted over here. Because without the probes, there'll be no connection. With just the probes, I mean, there'll be no connection, and you won't be able to, you know, use the engines or anything. Unless you have a satellite in orbit, then you can just use this. Ultimately, that's up to you though. Okay, so that's good. Okay, and now we can decouple this. Oh yeah, there you go. Okay. And now I want to get these kerbals back first. So we'll just do that. So we end this mission with about a few thousand Delta V spare, so you could probably use this to go to, say, Duna. If you were going to Duna with this though, I'd suggest only using probes, because you won't be able to come back most likely, but if you can, then go ahead and use kerbals, but I don't really. If I do want to go and do this on Duna, then I'd use the an extended version of this rocket, and just to be safe. So I'm just going to bring these kerbals in, and then once they've landed, I'll go and do the lander. Okay, so they're fine. And now this is in orbit. I think this is a great time to try and land this. Except it's in the dark, so I'm just going to climb up here to get to the other side. Hang on. So about there is good. Let's just time warp it to here, and then we're going to fly it. Okay, so we're in a good position now. So first of all, I'd unlock this, and I'll bring these to 0, and unlock these, and I'll extend them to maximum. Once these are extended to max, and then lock both of them. Now with the engines, won't mess up. Click control from here, so it isn't controlling from here, because if you're controlling from here, then your retrograde will be this way, but if you control from here, your retrograde is that way, so you're able to land fine. See, I activate the engines, we have this much, 1780 Delta V. We're going to wait until we can see some relatively flat area, and probably over here somewhere. Yeah, I'm going to burn now. I want to try and land here if I can, or just here actually, that's better. Time up a bit forward, we're going to burn more. Good. No, I'm going to land here then, that'll be fine. We have plenty of Delta V and plenty of time to take this pretty carefully, so I'm going to burn down to about 50. Actually, that's good, okay. I'll leave it to go down a bit more. And then we can burn a bit. And quick. I I'd say take it as slow as you have to. If you land on the moon a lot and you can do this at like a high speed and save a lot of time, then do that. But if you haven't really landed on the moon much before, just take it slowly so you don't end up crashing. I'm always trying to look for some flat land, because if you land in crater, then that's not great. Drop in, and now it's landed. Going dark, and you can go around, you can drive. I'm just going to turn this up, and friction control. It'll make the rover a lot slower but a lot more stable. And there you go. That's how you land a rover on the moon using robotics.